Hi everyone. Today we'll discuss problems based on center of mass. So you can see this fourth example. So a uniform circular plate of uniform thickness has a diameter of 56 centimeter. A circular portion of diameter 42 centimeter is removed from one edge of the plate. Find the position of the center of mass of the remaining portion. So here you can see this diagram. So this is the circular plate of diameter 56 centimeter, and this much part has been removed out of this, whose diameter is 42 centimeter. This has been removed. This part is the removed part and this is the main plate area. Now we have to calculate the center of mass of the remaining part, yani this part we have to calculate. Okay, so here we can see the mass of the plate is pi r square rho, where rho is the mass per unit area. If you consider the area as pi r square and rho is the mass per unit area, then the total mass we can consider pi r square into this rho. So the mass of the plate is 28 is its radius, because 56 centimeter is the diameter, so 28 is the radius, so pi r square into rho. So that becomes the mass of the plate. Now mass of the portion which is cut off, suppose it is m1. M is the mass of the entire plate, m1 is the mass of the cut off part. So it is again pi r square rho, so its radius will be 21, so it is pi 21 square into rho, and is effectively at its own center. Yani the center of mass of this, it is its geometrical center, so somewhere it will be acting at its own center of mass. So this is the center of mass, suppose, of this cut portion. Okay. Now the mass of the remainder. So mass of the remainder, it will be equal to how much? This total mass minus this mass. So corresponding to that, this mass minus this mass. So that gives you this relation: pi r square into this rho minus pi 21 square into this rho. So that is the mass of the remaining part. Now we can calculate the center of mass of the remaining part. So again, just using the standard concept, axiom m1 x1 plus m2 x2 plus m3 x3 and so on, divided by m1 plus m2 plus m3 and so on. So that gives you axiom, that is how much? This we have to calculate, so we can just substitute it. m1 is equal to how much? Pi 21 square rho, so pi 21 square into rho, plus pi 28 square minus 21. This 21 is what? m1 x1. So this represents x1, because this total is 42, this is 21, and this is its center of mass. So this distance from this is taken as the reference point. This point is taken as your reference. From this reference point, its center of mass is at a distance of 21. So it is m1 x1 plus m2 x2, means of the remaining. So pi 28 square minus 20 rho into x of the remaining. If it is suppose m, so of the remaining, it has been considered at a distance of x. The center of mass from this edge, it has been considered at a distance of x of the remaining part. So simplifying this relation, we are calculating this x is equal to 37 centimeter, because this is equated to what? This 28, and 28 is what? The center of mass of the bigger part, yani of the circular plate. So from here we can simplify it, and you will get x is equal to 37 centimeter. It means of the remaining from this point, it is at a distance of 37 centimeter. This total is 56 centimeter, this total is 42 centimeter. Of the remaining, it is at a distance of 37 centimeter. Now let us consider the next question. So if you consider the next question here, almost it is similar to the previous one. So now let us see this. A circular section of radius small r is cut out of a uniform disc of radius capital R of the disc, and this of radius is small r. The center of the hole being r by 2 from the center of the original disc. So suppose center of this original disc, it is this. From this its radius it is at a distance of r by 2. The center of the original disk, the center of the hole being r by 2 from the center of the original disk. Locate the center of gravity of the remainder, center of gravity or center of mass of the remainder. Again, this part has been taken out of this circular section, so we have to again calculate the center of mass or center of gravity of the remaining part. So again we can consider that if rho is the mass per unit area of the disk, okay, then the weight of the disk, it will be how much? Pi r square rho into g. We are considering this weight here just because the term used is center of gravity, not the center of mass. So pi r square rho into g, acting at its own center, that is O. Okay. Now the weight of the cutoff portion is pi small r square rho g, acting its own center, that is P. The center of mass of this part is this, center of mass of the entire part it is this, and they are supposed to be concentrated at their own center of masses. So that's what we have considered here. Now acting at its center P, and OP is equal to how much? R by 2. That is also given. This center of mass is at a distance of r by 2 from the center of mass of the original part. So that is also given. So let the weight of the remainder, that will be equal to how much? This entire weight, this weight of this entire section minus weight of this. So again you can consider this. Again, taking moment, when we calculate the center of mass, and that you get the relation m1 x1 plus m2 x2 upon m1 plus m2, that is nothing but the in equilibrium, the moment from the left side, it should be same as moment from the right side. Either you calculate clockwise or you calculate anti-clockwise. So that's why we have considered taking moment of these weights about the point O, about this point O. Pi r square minus r into rho g into OQ. OQ means this distance, because we are calculating moment about the point O. So moment about this point O, and at this point the remaining weight is acting. So remaining weight is acting. So force into its perpendicular distance, that gives us the moment. Force into perpendicular distance is the moment. So pi r square minus r square rho g into OQ. This force into this perpendicular distance, it should be equal to how much? Pi r square rho g into r by 2. This force, any weight here, into this r by 2, because we are taking moment of this force or this force about this. The system is in equilibrium, so anti-clockwise moment has to be same as clockwise moment. So considering that concept, we just simplify this. You will get OQ is equal to this divided by this, and from there we are getting this relation. So this way we can calculate the center of mass. Directly, if you want to use the formula, just put values in that formula and you will get the similar relation. So this is just a basic concept behind how we are calculating the center of mass relation, that is xcm is equal to m1 x1 plus m2 x2 upon m1 plus m2 and so on. So what is the logic behind that concept and all that. Now see again this question. A cylindrical vessel of radius 1 meter, cylindrical vessel of radius 1 meter and height 2 meter. If you consider this cylindrical vessel, okay, of height 2 meter and radius 1 meter. This radius is 1 meter. Okay. Is half filled with water. This is half filled with water. Find the center of mass of the system consisting of cylinder and water. Find the center of mass of the system consisting of cylinder and water. The cylinder has mass 10 kg per square meter and density of water is 1000 kg per meter cube. So here you can see the cylinder has a mass of 10 kg per square meter and density is also given. So again we can calculate using the similar concept. The mass of the cylinder, that is the vertical portion, okay, is 2 pi RH into this. So from here we can calculate. These are the standard relation and you can just substitute the value. at a height of 1 meter from the bottom, because its total height is 2 meter. Again, geometrical center, it will be at a height of how much? Half of this, that is 1 meter. So this is 1 meter. The mass of the water, again we can calculate this one. Volume into density, pi r square h, that becomes the volume into density, so that gives you the mass of the water. At a height of half meter above the bottom, and mass of the base is 10 pi at a height of 0. Okay, at the mass of the base, so that will be what? At the bottom, so that's why it is mentioned that one. So from here again, center of mass, that will be how much? m1 again x1 plus m2 into x2 divided by m1 plus m2. For this, x2 has been taken as 0, m1 x1 that we have already considered. Simplify this, you will get the center of mass at a distance of 0.514 meter. So this way we can calculate it. I hope this is clear. So these are all similar questions, just using the direct formula. Similarly, simply masses are directly not given, height, radius, all these things are given. Using all geometrical relations, we can calculate the volume or the area, and from there we can calculate mass, substituting, and we will be able to simplify it. Now in this question you can see only the geometry of the diagram has changed, and we will make use of that. Find the center of mass of the following L and T-shaped planks with reference to the frame indicated in the figure. So this is L-shaped and this is T-shaped. So we have to calculate the center of masses. So here you can just see, we have to consider two things separately. One is this part and another is this part. Similarly here, one is this part and another is this part. So its center of mass, it will be at its geometrical center, and its center of mass, again it will be at its geometrical center. Similarly, this center of mass, it will be at its own geometrical center, and this center of mass, it will be at its own geometrical center. This is one part and this is another part. So that way we will try to analyze, and again we will use the same concept, m1 x1 plus m2 x2 upon m1 plus m2 and so on. So here you can see, if you first consider the L-shaped as a combination of two planks, 20 centimeter into 4 centimeter. This is 16 centimeter and this is how much? 4 centimeter. Okay, so this total becomes 20 centimeter into 4 centimeter. Width of this, it is 4 centimeter, and another is 8 centimeter into 4 centimeter. This is 8 centimeter, this part, and this is again 4 centimeter. Here it should be 4 centimeter. Okay, so 8 centimeter into this 4 centimeter. Now, if we consider center of mass of this rectangular lies at its own center. So center of mass of this lies its own geometrical center. Center of mass of this lies at its own geometrical center. So that gives you m1 is equal to 80 into rho, x1 is equal to 2 centimeter. Here m1 80 rho is the mass per unit length. So from that, or rho, if it is considered mass per unit area, then 20 into 4, so 80 square centimeter. Rho is mass per unit area, so using that we will get 80 rho. x1 2 centimeter, x1 x coordinate, if you take O as the origin and this is 1, so somewhere here it will be its center of mass. This object it will have, so x coordinate it will be how much? Half of this 4 centimeter, so it is 2 centimeter, and y coordinate it will be equal to this much. So m1 x1 plus m2 x2 upon m1 plus m2. Similarly, if you consider this, so this is 8 centimeter, so geometrical center from here it will be 4 centimeter. Already this is how much? 4, so 4 up plus this 4, that is 8 centimeter. So that's what you can see, this x2 as 8 here. Okay, 8 centimeter, half of that geometrical 4 centimeter, but that 4 centimeter is from this point, but we have to take it from the origin or reference point. Same reference point has to be taken for each and every block or each and every section. So this is 4 centimeter, this is 4 centimeter, so that makes it 8 centimeter. So this is 8 centimeter. Substituting, you will get this 3.7 centimeter. Similarly, y coordinate, this y coordinate and y coordinate too. Here again, its y coordinate. This is 4 centimeter, so this is at a distance of 2 centimeter. This entire is how much? 16 centimeter plus 420, so this will be at a distance of 10 centimeter. So that you can see 80 rho into 10 plus 32 rho into 2, this 2. So m1 y1 plus m2 y2 upon this. Simplifying, you are getting this. It means x and y coordinate somewhere here, if the center of mass lies of the entire system, suppose somewhere here, here or anywhere, so it will be x bar and y bar. So 7.7 centimeter and 3. Now we can locate it from this, because O is the reference point. So from here 3 centimeter this side and 7.7 centimeter this side. This total is how much? This total is 20. So 10 is somewhere here. So somewhere here 7.7 and 3.7. So 3 point, this is 4 centimeters. So somewhere here is the, yani just you can consider center of mass somewhere in front of this line, somewhere here, which is 3.7 and 7.7. So that is the center of mass of this entire system. Similarly, we can calculate for this T shape. So just calculate its center of mass individually, which is its geometrical center. Similarly, this x and y coordinate of this point, x and y coordinate of this point, and from there again using m1 x1 plus m2 x2 upon m1 plus m2, we can calculate its center of mass. So again you can see this, we have substituted the values here, and you will get again this x bar as well as this y bar. Simplifying, x coordinate it is coming as 0 and y coordinate it is coming at a distance of 4 centimeter, from which is this is y and this side it is x. So from here we have taken, so that way we can again calculate this. So just these are simple questions, just calculate x coordinate and y coordinate of this part, x and y coordinate of this part, considering one point as the origin. It is not necessary that we should take this as origin, this origin. We can take again any point, but standard convention is what? Generally the left side extreme corner is taken as the reference point. So considering that, we can consider this as the reference point. Again from here this distance, x coordinate, and this side y coordinate, and that way we can calculate it. So these questions again we will discuss in the next video. Thank you.